Okay, guys, we're gonna start now. I'm still just sharing the link to the learners who are going to attend this class today. So I'm just sharing the links now, but I hope most of them have got the link now. So they will be joining us. Most of the learners will be joining us very soon. Will be joining us very soon. So I still have three learners here. Let's just wait for them to be five, then we can continue with our lesson. Sorry, I don't know what's wrong with my voice today. It's not that clear. Maybe it's the flu because of the season change, right? It's the flu because of the season change. And then we're going to look at everything about Euclidean geometry, right? I've prepared everything about Euclidean geometry, and then I believe it's gonna help you a lot, right? After this lesson, I don't think you will see Euclidean geometry as something difficult anymore, right? You won't see it as anything something difficult anymore. So this class is going to change you, right? It's going to change you. So let me just remind the others. Um, after this lesson, you always can. Okay. Then go still five. So let's just give them a moment to join, right? Let's just give them a moment to join. Let's just give them a moment to join. So I'm just gonna start now. I'm just gonna start now. Let me just start now. Okay, it's fine. So let's start. Um, you see, this is the first theorem, right? This is the first theorem. Here we started with I started with the theorems of the circles, right? So the theorem number one is states that the line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. That's theorem number one, right? So if you see a line from center being perpendicular to the chord, it means that it is joining the center of the circle, right? The midpoint, right? So it means that the theorem then will say either we'll be proving that this line equals to this one or these two lines are perpendicular, right? So I'm sure with these ones, all of you understand it first theorem, and then the second theorem, you have to understand also these other diagrams, right? Because this one, obviously everyone knows it. But you have to look out for this one also. It's also equal to two times that one, right? And then here, most of the learners make mistake to say that maybe here if it's 50 degrees, they will say here is 25. degrees because we say angle at center times angle at the circumference, and then it is wrong, right? It is wrong because the angle which is two times bigger than this one is this other angle this side, right? So that is the mistake that most of learners does, right? That's the mistake that a lot of learners does to mix up the two things, right? So it is, you have to understand all these diagrams, but we're still gonna look at them in the equation form, right? Sorry. And then another theorem is that the line on the semicircle is always 190 degrees, right? Angle subtended by diameter is always 90 degrees. So that is another theorem that you have to understand it, right? That if you see a line subtending 90 degrees, then it's a diameter, right? If you see a line subtending 90 degrees, then it's a diameter. So if you see any triangle like this, like even if you see it anywhere, you see a triangle like this, all right? You see a triangle like this, and then they show you that here is 90, right? And it's A, B, C, right? It's ABC. They will ask you prove that ABC lies on the second, right? They can lie on one second. So they can lie on the one second because the AC will be a diameter and it will be subtending that B. AC will be a diameter and it will be subtending that B on the circumference of a second, right? So that is something that you have to take very careful of, right? When they say prove that ABC is a second, right? There is a circle that touches all those vertices of that triangle. Yes, there is a circle that touches all the vertices because I see there is 90, right? So that is the theorem, line article, diameter subtends 90 or angle on the semicircle is equals to 90, right? And then go to this one. This also is very important theorem that line on the same segment, right? So when we say line on the same segment, let me show you. So we draw a line here, right? If we draw a line there, and then it means that we've got two segments. We've got a major segment this side and a minor segment this side, right? Chords divide our circle into two segments, a major segment and a minor segment. So that one will divide our circle into two segments. So we've got major segment and a minor segment, right? And then since this angle is from the segment here, is from this segment AB, and this one also is from the same segment AB. It means that they are equal, right? We say that angles on the same segment. Some will say angles are tended by the same arc. When they talk about arc, obviously they're talking about this arc here, all right? Or some will say angles subtended by the same chord or angle on the same segment. So it's the same thing, right? And then we go to this one now where we talk about a cyclic quadrilateral, right? So with a cyclic quadrilateral, we know that opposite angles always equals to 90 or 180, right? And then what they will ask us to prove a cyclic quadrilateral. Sometimes they'll just draw a quadrilateral here, and then they give us maybe here is 70 degrees and then here is 110 degrees. So obviously this figure, even though when we don't have a circle on it, we know that it's a cyclic quadrilateral because we see that, okay, its opposite angle gives us 180 degrees. So yes, it's a cyclic quadrilateral, right? So that is also very, very important, right? That is also very, very important for you to understand, right? Or that they will say prove that a figure is a cyclic quadrilateral, and the figure that they are asking you to prove, sometimes it won't be on the second, right? Sometimes the figure they will ask you to prove that it's a cyclic quadrilateral, it won't be on the second, right? So it's going to be very, very crucial for you to observe that, right? It's going to be very, very crucial for you to observe that. So I don't know what's going on, but am I still? I don't know if I'm still audible. So let me just confirm that yes, I believe I'm still audible, right? Okay. So that is what we need to understand about the cyclic quadrilateral, right? We need to understand our cyclic quadrilateral. Now let's go to this figure now. Let's go to another one. So here it is a cyclic quadrilateral because when we add the two angles there, um, when we add the two angles there, um, okay. So when we add the two triangles there, then when we add the two angles there, then they give us 180, right? So also, when we talk about this one, we'll talk about the exterior angle. This exterior angle will be equal to this one, right? And then why are they equal? Like for example, if I've got a cyclic quadrilateral here, let's say this is my cyclic quadrilateral there, all right, and then I know that here is 60 degrees, and then the opposite will be 120 degrees obvious, right? So what is this angle here? This angle is the sum of angles on a straight line, which is going to be 180 minus 120, which is going to give us 60 degrees, right? So that is the exterior angle of a cyclic quadrilateral, right? So is just that straightforward, and then we go to another theorem where they say a tangent to a circle is perpendicular to the radius at the point of contact. So if we know that this one is a tangent and this one is a radius, then they are perpendicular, right? If they are meeting the circle at the same point, right? They are meeting the circle at the same point, they will be perpendicular. So, and then we'll go to the other theorem that the tangent from the same point to the circle, right? The tangents from the same point to the circle, they will always be equal. Our AB will always be equals to AC, right? Because they all are all tangent and they are all coming from A, right? So that means that we have got a kite here also, because if you know that, okay, this one and this one will be giving us 90 here. And what else do we know? We know that this angle and this one will be equal. And then we know that this one and this one will also be equal. And this one will be equal to that other one, right? So those are the things that we cannot ignore, all right? Those are the things that we cannot ignore. These figures are very, very important, right? Those are the things that we cannot ignore. And then we've got the tan chord theorem, right? So the tan chord theorem is the angle between the tangent to a circle and the chord drawn from a point of a contact in the equal or contact in the equal is equal, okay, it's a mistake, is equal to an angle in the alternating segment. So this one here, you can see that, okay, is this chord here and then the tangent here. So this one to be equal on the other segment, on the angle subtended by this chord on the other segment. So obviously that chord is subtending that angle there, right? So that is our tan chord theorem, right? That is our tan chord theorem. So we have to remember to know, understand our tan chord theorem, right? And then we go to theorem converse. So converse is almost like an opposite, right? Converse is almost like an opposite. So we just straightforward this one, right? So if we're talking about tan chord and then the converse, just means the same thing, just in reverse, right? Like for example, if we say today is Tuesday, right? And then tomorrow will be Wednesday, right? It means that if we are starting from Wednesday, we can start by saying tomorrow is Wednesday, therefore today is Tuesday, right? So that is the converse. So to start with the other thing, it's a converse. So we know the theorem, what the theorem says, right? And then when we say it from the reverse, then we say, oh, we are doing a converse, right? So it shouldn't confuse you when they say converse, right? And then how to prove a quadrilateral is a cyclic quad. How to prove a quadrilateral is a cyclic quad? Here it is, right? To prove that a cyclic quadrilateral is a cyclic quad, it's either you're going to prove the exterior angle equals to this one, all right? Or someone might prove that this angle is equal to that one. They've proven cyclic quadrilateral because they are on the same segment. They're subtended by this one, right? Or someone will come here and prove that this one here is equal to this one there. And then they are all proven that cyclic quadrilateral, right? So here are the conditions. I'll share this document with you guys. So here are the conditions to prove a cyclic quadrilateral, right? They are very, very important. Everyone should understand um all these conditions, right? Because they are definitely going to ask you about the cyclic quadrilateral, right? And then how to prove that a line segment is a tangent to a circle. To prove that a line segment is tangent to the circle, it has to be tan chord, right? That's the only thing we know is tan chord. So if we prove that this angle here is equal to this one, although if we don't have this circle here that was drawn, then we know exactly what it is. That this is what do you call this point EDB. It's EDB or EDR. EDB lies on the same circle, right? Just because we know that E1 or B1 is equals to E, all right? B1 is equals to E, it gives us that that circle is that line AC is a tangent to circle passing through E, B, and D, all right? So let's quickly move forward. Now let's go to the proofs, right? Okay, these proofs are very, very important. So when you prove, guys, you make sure that you know them in order. This order is very, very important, right? Because you cannot use this theorem here to prove this theorem. That's wrong, right? That's wrong. We start with the theorem number one, then we can use one to prove two, we are fine. And we can use two to prove one and two to prove number three is fine. And we can use one, two, three to prove number four is fine. But don't use theorem number four to prove theorem number two, you won't get a mark there, right? You won't get a mark for that, right? Okay, so let's start with this one. They are saying now, prove join, okay, the line drawn from the center to the circle perpendicular to the chord bisect the chord. So this one, to prove this one now, we just need to draw this line. These are the construction, right? These are the construction that they will give us mark for, right? And then we mentioned that this side is equal to this side, they are D, right? And then this one is common to both triangles, and then which means that, and we know that here is 90, here is 90, it was given that your line is perpendicular. So we've proven one side and the hypotenuse. So we have proven that these two triangles, triangle AOM and triangle DMO, OAM and triangle OBM are what? They are congruent, right? Which means if they are congruent, obviously this side and this side will be equal, right? And then we've proven that at the first theorem, right? So when we come to the second theorem here, we remember there was no this line, right? This line was not there, right? So that's where we start. They will bring something like this. They will bring something like this, and then they will bring something like this. To bring something like that. Let me just put it normal in a normal way because I don't want to spend my time doing this, right? They will draw something like this and they will say prove that here, if here is A, B, C, O, right? They will ask you to prove that O, let me call it O1 or let me just name it BOC is equals to true angle A, right? They will ask you to prove that, and then when you have to prove this one, the first mark that you should collect is the mark for constructing. You construct a radius there, and then it passes a bit a center, right? And then you have something here. You will name it anything you want there, and then after that, you will be talking about exterior angle of this triangle. That this angle and this one, when we add them, they give us this, but also we know that this side is equal to this side. They are already, and then which means that 2 of this side is equals to this figure, this one here. And then again, you do the same on the other side, right? So here is the proof. I will send you all the document of these proofs, right? I will send you all of this because they are very, very important, right? At the end of this lesson, I'm going to send you this document, right? And then when you have to prove that angle at center, your the opposite angle of the cyclic quad, they are equals to 360. We talk about this one here, the revolution around here. We talk about the revolution around here. The revolution is what? Is 360, right? You know that there is 360 degrees. And then after that, what do? We say this one is 2 times bigger than that one. And this one is 2 times bigger than this one. Then after them, we say O1 plus O2 is equals to 2B plus 2D, uh, 2D plus 2B. And then after that, we equate them to 360 that we started with. And then we divide by 2. That's very straightforward, right? And then we've got our time code here, right? We've got our time code there. So to prove a time code also is not difficult at all, right? It's not difficult at all to prove a time code. You all should be able to prove a time code, right? I'm 100% sure you are able to do that because those are the things that we cannot go without, right? We cannot do it without understanding them. All of us have to understand those things. Those are the key to our mathematics, right? Everyone has to understand them, all of them, right? So that's going to be very, very crucial in our mathematics, right? That's going to be very crucial in our mathematics. And then we've got these corollaries that are also very important, right? That equal chords subtend equal angles at the circumference of the circle if they are on the same circle, right? And then also they will subtend also equal angle at the center if they are on the same circle, all right? And then again, equal chords of equal circles then This time is when the two circles are equal. And how do we know that the two circles are equal? Because their d are equal, right? So if we've got two chords that are, we've got two circles that are equal, it means that the equal chords will be subtending equal angles in both triangles, right? So that one is also very, very important for us to understand, right? It's also very, very important for us to understand. So let's go to this one, keywords and map, right? So this one is very, very important, right? You have to understand all these things. When parallel lines are given, how to prove the lines are parallel. Angles are angle or line bisectors. Triangles information we've got an isosceles triangle, that's very important. Exterior angle of the triangle, and then we can have an equilateral triangle in rare cases, right? And then when you must prove two sides are equal, the center of the circle given, diameter, angles formed at the circumference, chords in a circle, cyclic quadrilateral given, how to prove that a quadrilateral is cyclic, and then tangents to given tangents to circles given, right? How to prove that a line is a tangent of a circle, right? So those are the things that we all have to understand, right? We all have to understand. So let's go to proofs, and then with proofs, these are the things that they will ask us to prove. They will ask you to prove that the line drawn from the center is perpendicular to the chord. Okay, there's all the proofs that I've shown you. But at the end there, they are saying a line drawn parallel to one side of a triangle divide the other two sides proportionally, right? And then equiangular triangles are similar. So this one, E and F, is basically for grade 12, right? Okay, and then corollaries divide derived, right? So we've got angles in a semicircle, equal chords subtends equal angles at the circumference. So all these they are corollaries, right? So those are not really a theorem, right? Those are not really a theorem. Like angle at the semicircle is equals to 90. It's not really a theorem, it's a corollary, right? Okay, and then prove that okay, this one we just been on it. And then here now we start with our lesson, right? This is exactly where our lesson starts, right? The information next to the diagram thoroughly, right? Read, read, read the information next to the diagram thoroughly. Don't make a mistake there, right? Don't assume, don't do any other thing. Just make sure that you read everything on the statement. Just make sure that you read everything on the statement, and then you are able to answer the questions, right? You start by reading everything. Like look for the keyword, and then like the keyword can be uh, tangent, and then if you see a cyclic quadrilateral, and then never assume something. Don't assume that a certain line is the diameter of a circle unless it is clearly stated or unless you can prove it, right? You don't assume anything. Don't assume that a point is the center of a circle unless it is clearly stated circle M, which means that M is the center, right? And then the circle with each point M, then M is the center also, right? And then we've got this one. The following are some forms of logic application applicable in proof of theorems and riders, right? So if A is equals to B and B is equals to C, then obviously A will be equals to C, and then the reason will be they are both equals to B, right? And then if A plus B equals to C, and then D plus B equals to C, then A plus D equals to D plus B, right? And then so A is equals to D, right? So those are all other some important information, right? And then if A is equals to B plus C and B is equals to D, then A is equals to D plus C. So those are also very, very important, right? And then take note of the following terms are given, right? So if they give you a center, if they say this is a center, once they say a center, you have to think about all this that I have written there. Like if you see a center, you know that they can be joined by chords to form an isosceles triangle. And then number two, angles opposite equal sides and can be there, right? You can have an isosceles triangle and then sides opposite equal angles because of an isosceles triangle because those chords will make a triangle, right? And then angle at center will be two times angle at the circumference if there's an angle subtended to the center. So all of these things you have to think about them. I will also show you how to think about them, right? And then if they give you a tangent, you all know the things about the tangent. They give you parallel lines. Parallel lines, you Parallel lines you have to think of um, corresponding, alternating, co-interior, right? That's when they talk about parallel line, you have to think about those things, right? And then angles, okay, if they give you a diameter, it means that you know that angle obtained by diameter is equal to 90 degrees, right? And then diameter perpendicular to radius or diameter, right? Tan is perpendicular to radius or diameter, or we know that diameter is 2 times radian, right? So those are the things that you have to think of. And then if they give you a cyclic quadrilateral, you know their opposite angle, the exterior angle. That's what you have to think about, right? And then if the for equal lines, they give you these two lines are equal. You have to think about equal cos subtends equal angles. Maybe if they form a triangle, then you can talk about a triangle as an isosceles triangle, right? But if they don't form an angle, that's when you can only think about equal cos subtends equal angles, right? And then we can have angles. They give you angles, then we know that we can think of complementary angles add up to 90, and then supplementary angles add up to 180. And then if they give you equal angles, they give you equal angles, you can think of these angles might be alternating, they might be corresponding, there might be opposite angles of the isosceles triangle, right? There might be one of those things, right? So you just forgive me about that. You just forgive me about that. I'm in class. So let's go to the next one. So revolution, and then you have to think of 360 also of revolution, right? You have to think about that also. And then now let's go to this one now. This one I just took it and put it here because I want you to understand the things that I was showing you here. All right. Read on the statement and then analyze before you even look at the questions. Right. I didn't take the questions of this question paper. I just took the statement and the diagram, right? So they're saying in the diagram, ACD is drawn. ACD is drawn. So ACD is drawn. So I've got triangle ACD there. Means that ACD is a triangle, right? Triangle ACD is drawn with points A and D on the circumference of the circle. C and A and D. So these points are on the circumference of the circle. And then and AD in the circumference of the circle, and then CD cuts the circle through B. So B is the circle there, right? And then they say P is a point on AD. P is on AD, okay? P is on AD is fine. And then with CP bisector of CP with CP, CP, CP bisector of what? CP bisector of CP bisector of angle what? Of angle ACD. Okay. So it's the bisector here. It means that this angle. So let's talk about bisector, right? So this is the here is the first word, right? Here is the first key word, right? Bisector. So let's talk about this bisector. What does bisector mean? It means it cuts angle into two equal parts, right? So because of the word bisector, because of the word bisector, we know that what? We know that C, or we can say PCB or PCD. PCB, alright? PCB is equals to what? Is equals to C1, alright? Therefore, we know that C1 will be what? Will be 25 degrees, right? Because of what? Because of the word bisector, right? Because of the word bisector, we now have this one as 25 degrees, right? Okay, so let's go to the next step. They're saying CP cuts the chord AB at T. Cuts AB at T, okay? So it cuts the chord AB at T. And then, okay, if they cut each other because they've given us this angle there, obviously, because because of the word cut, those lines are cutting each other at T. Cut at T. So it means that we know that T3 is equals to 65 degrees. And then because of vertical opposite angles, all right? And then we also know what? We also know that T2 is equals to 180 minus 65 degrees. Of the reason what? Angles on this sum of angles on a straight line, right? Sum of angles on a straight line. And then what else? Okay, we've got that, right? Okay, and then HT, and then say AT is equals to AP. AT is equals to AP. So we've got an isosceles triangle there, which means that this angle and this one are equal, right? And then it's because what? It's because of equal length, right? It's because of AT equals to AP, right? So AT equals to AP gives us that P 2 is equals to 65 degrees. Angles opposite equal sides, right? So what else did they give us? They give us that PCB is 25. So that's it. It means that we could have find this angle, and after finding it, then we can find this one. And then after finding it, this one is also easy because of the exterior here of a triangle. And then after that, this one is also easy. And after finding that, and this is going to be easy, and this one also is going to be easy. And since we've got this here and this here, it means that this is also going to be much easier. And then since I've got three sides of a quadrilateral, it means that the sum of angles on any quadrilateral equals to 360. So this 360 will give us here, and then here we can use the sum of angles on a straight line, and then we'll be done with our figure, right? So you see, you can find everything. So there is nothing that they could have asked us here and we couldn't answer, right? We understand everything because of the statement only before we even go to the question, right? So let's look at this one again. So in this one, what did they say? They're saying in the diagram below, the circle with center O passes through A, B, C, and D, right? The circle with center O passes through the point A, B, C, and D, right? So now they are saying what? They are saying AB is parallel to DC. AB is parallel to DC. So, okay, the second with the center O. So the first key point is center O. So with center O, that's the first, what do you call? That's the first keyword, right? Passes through point A, B, C, D. A, B, C, D might be a cyclic quadrilateral. Nope, it's not a cyclic quadrilateral because they didn't close there, right? They didn't close there, so I'm not going to talk about any cyclic quadrilateral here. But what I'm going to, another keyword is going to be this one, parallel lines. Which lines are parallel? This one and this one, right? So I've got parallel lines now. It's another keyword, right? And then BOC equals to 110 degrees. What is our 110 degrees? Here is the 110 degrees, right? So it means that we've got that one. Okay, it's fine. Not really a keyword, but it will help us, right? So we have to talk about one and that 110, right? And then they are saying cos AC and BC intersects at E. Two chords are intersecting at E. Okay, so it's this one and this one, right? They intersect here, right? So which means that the opposite angles there, vertical opposite angles there will affect, right? Okay, and then they're saying this or this one are just joined, right? So now we just need to go back to our keyword. Our keyword, the first one is center O. Central. Oh, so do I have a diameter there? I don't have a diameter, so I won't talk about diameters at 10 to 90, right? I'll only talk about the angle at center to times angle at the circumference because O1 is subtended from BC, right? So what else does BC subtend? It also subtends D and A, right? So we'll talk about D. What do we call D? 2D is equals to O 1, right? And then it's angle at center to times angle at the circumference, right? So, which gives us that that D is equals to what? D is equals to D is equals to what? D is equals to okay, it was 110, so it's going to be 55, right? It's going to be 55. So our D will be 55 degrees. That's going to be our D, right? And then after that, we know that it's also subtending A, so A will also be 55 degrees because it's also subtended from the same place where our center is subtended from, right? And then what else? Because of center, that's all we can talk about because the center, right? So for that, that's all we can talk about because of the center, right? And then we've got chord, the chords AC and BC intersect at E. Our chord AC with AC, our chord AC and BC intersect at E. Okay, we've talked about that one. Oh, let's talk about our parallel lines, right? Now we need to talk about our parallel lines, which is AB. is equals to parallel to AD, right? AB parallel to AD, parallel to AD, right? So since we've got parallel lines, what do we think of? We know of what we know of the parallel lines give us what? They give us they can alternate or correspond or something, right? So we can see that okay, I've got a Z there. So I know that B1 is equals to D, and then already we know that D is what? We calculated D, we know that D is 55. So even B1 is going to be 55, right? Even B1 is going to be 55. And then what else? Where is another Z? I have another Z. Yes, I have got this one here and this one there. All right. So that is another Z, right? That is another Z. So it's going to be what? It's going to be, I will call it ACD. Have ACD equals to what? ACD equals to A, right? ACD equals to A. And then the reason is another Z. They are also alternating, right? So we can see that we can find a lot of things by just analyzing the diagram, right? Since we've got this angle now, we've got this angle, we've got this angle, and what else? And we've got this angle, all right? So where can we go next? And then we've got this one here. And then what else can we need? What else can we need? Maybe they were going to give us more to calculate something more, but for now, that's what we could have found, all right? From the statement that they've given us, that's what we could have found, all right? I made, okay, I made only 4 examples, all right? Okay, so let's look at this one now. This one in the diagram below, O is the center of the circle, BD is the diameter, okay? BD is, now we've got the diameter, and then of the circle, GEH is a tangent, and then we've got a tangent, and then to the circle SE, and then we've got F and C are 2 points on the circle, FB, FE, BC, CE, and E1 is equals to, and BE are drawn, okay, and then there's E1 is 32 degrees, and then E3 is 56, okay, so there we are, we've got everything there, right? So first of all, I will look for a cyclic quadrilateral. Cyclic quadrilateral is also one of the very easy um, topics, right? One of the easy theorems, right? So I can see that, okay, I've got a cyclic quadrilateral there, right? I've got a cyclic quadrilateral, so I will start with the cyclic quad, right? I'll start with the cyclic quad. So my cyclic quad there is going to be what? I've got cyclic quad, which is BCEF. I've got cyclic quad, which is BCEF. Right, so when I've got cycle quad BCEF, what do I know? It means that I know that the two angles, this angle and this one, they should give me 180, right? I know that C angle C plus angle F equals to 180 degrees, right? And what else do I know? I also know that this angle and this one also give me 180 degrees, right? I also know that B and E, like we call it FBC, FBC is equals to, or not is equals to plus, right? So plus what? Plus FEC, FEC, and then equals to 180 degrees, right? The same reason, all right? And then that's all about the cyclic quad. Do I see any other cyclic quad? Yes, I do see another cyclic quadrilateral. What is the next, or wait, the next cyclic quadrilateral? The next cyclic quadrilateral that I see is going to be this one here. Going to be this one here. You see this one there, and then which means that this angle and this one will give me 180, and also this one and that one will also give me 180, right? So I'm not gonna write everything down again because I've done that, okay? So I've shown you another cyclic quadrilateral. So now let's go to our key point. Our key point, we've got O center, right? That's what O center gives us. They say, okay, or O, that O is the center. We don't have any angles subtended at the center, so we won't have what we have. We've got certain angles subtended by diameter, which is going to be 90 here, right? So that angle is going to be 90, which is going to be what? The angle I'm talking about is going to be DED. DED is equals to 90 degrees, right? Because it's subtended by the diameter, right? So that's it. That's what we know. And then now let's go to the next one. The next one, that's all we know. That's all the center give us here for now. And then now let's go to what? Um, Diameter. Okay, center and diameter. We are fine with these ones of the circle. And GEH is a tangent. Now let's go to our tangent. And then our tangent, remember this one here can give me tangled with that one. All right. So tangent gives us what? The tangent gives me that E1 is equals to B2. E1 is equals to B2, right? And then it should give me that B2 is equals to 32 degrees, 32 degrees. And then what else? And then also this one here should be equals to which one? Should be equals to this one then. All right. I don't know if it's gonna help us, but we should mention and mention it, right? We should mention it that the your C E H is equals to um EBC.